Okay, so let's talk about what we came up with here. For addition, what are some words or phrases that you oftentimes hear? Go ahead, Sarah. Can you give us one? Exactly. Sum is probably the most commonly used one. So that's one. Anything else? So what's that? Add, of course. I'll just highlight that because we know when you hear add that it means to add, right? Quinn, what do you got? Combine, okay. Sometimes combine could mean a couple of different operations. Within a certain context, maybe, but I'm not going to write that because it could be something else, too. Isaac, what were you thinking? Plus, yeah? Right? What do you mean gives? Okay. Like he has 2 apples and he's given more apples or something like that. Okay, yeah, I mean, I guess that's not a common one, but that's certainly one. Okay? Yeah, Leah. Say that again. Additional or additionally, yeah. Again, I'm not going to write that because that's the root of this. There was one in the bell ringer. No, I'm sorry. I take that back. It was the academic bell ringer. You had one for subtraction. I'll get to that. Think about the one we had for the bell ringer. And then think inverses. What do you think? Sarah? Yeah, more than. So along with more than, oftentimes makes you think greater than. And there's one more that I want to put there, and that is increase. These are just phrases that I've heard over the years that mean to add, to put them on. So subtraction, we just saw less than is 1. Anybody come up with more different phrases? Brendan? Minus? Yep. Minus works for sure. Jack? Takes? Like, how about I put take away or something along those lines? Joey? Difference, yes. Difference is very common. Hard to write. Okay. Sarah, you got one? Decrease, of course. You have increase. Inverse with that would be decrease. Very difficult to write when you're 5 seconds ahead of the finished product. All right, it's like writing blindfold. Go ahead, Sarah. Yeah, subtract would be, again, the root of that. But that's a good list there. That's pretty common. And there are other ways that you can say it that I think contextually you'll hear them and you'll know what it means. How about multiplication? There's only a couple that we really need to write here. Go ahead, Leah. Product, yes, that's the most common one. We saw that on the bell ringer. Product. Hayden? Yeah, multiply by. Amelia? Times. Anything else? Zoe? Yeah, like when we talk about like the dimensions of something, like 3 by 4, and if I said the area of that, then you know that you're doing 3 times 4. So that's, I hear that. Good. Yeah, and that's what I've heard too. Double something, triple something, then you know you're multiplying by 2, by 3. Guys, of is another one along those lines too. Now, I didn't write the double, triple stuff, but that's there. I completely agree with Ellie. Division, a couple of them here. Jack. Each, how so? Tell me, how would you use that? You're thinking like how many would each get? like if you okay, so what do you do first before you determine how many each would get? Tell me about what happens before, Sarah. Groups or separated or split. Yeah, all of those words would then be what Jack is saying with like how many would each get. So like if you group something, oh man, oof. Separate it, whatever. Yeah, I know that there's not that big of a space in between there, but okay. I'm afraid to write now. Go ahead, Sarah. The quotient, yeah. Isaac? Dividend. Finn? Divided by, yeah. I'll leave that in there. Sorry? Into, yeah. I like that. And that might be like into or like split into or separated into, something like that. Okay, Hayden? Yeah, and you could write that. Yeah, divides in there, of course. The other one I've heard today is per. Not like the kitty, but PER. Okay? Like miles per gallon. You could divide miles by gallons to figure out your rate, things like that. Okay, so that's a good list. You don't have to memorize them, but just have to recognize them when they do come up and know what they mean. All right, here a quick exercise. Look down below. You have 4, I only have 3 up here. Let's just write some quick expressions for this, and I'm not going to make us spend much time here because we can get it. Read number 1. Tell me how you would write that as a numerical expression. Meaning, basically, just pull out the key word and tell me what operation it represents. Okay? So what do you think on 1? Brendan? 18 divided by 6, right? And I wouldn't even need you to simplify that. That's as far as you need to go. So you told me from before that I can't write that as 6 divided by 18, right? Not commutative, so that's where we got to go. How about number 2? There are none of the phrases that we wrote are even in number 2, but you can read it and contextually figure it out. Go ahead, Sarah. Yeah, it means multiplication. All right. Number 3. Go ahead, Jack. Mm-hmm. 250 plus 10. Yep. All right, and then the last one, which I don't have on there. There are 2 different ways to write the last one. Well, I've heard 2 throughout the day. Hayden? Well, 24 divided by 2 would be the right way. Yeah, 24 divided by 2. That's one way. Mikey, you thinking differently? 24 times 1/2? Or even, Isaac? Somebody, yeah, 24 minus 12 even. If you recognize half of 24 right away, you could take it away. So you could turn that into a division, multiplication, or even a subtraction problem. All right, let's turn that over. A couple of definitions here, and I've used this word already today a couple of times, simplify, which just simply means to put an expression in its simplest form. Basically, you guys would use the phrase solve it, like solve it as far as it would go. Although the word solve is not correct in this situation, take it down as far as it'll go. So on the bell ringer question, if you remember that one, if we would have simplified it, we would have got it down to, was it 0? Is that the one it ended up being? Yeah, we did it as far as we could go. To evaluate You're not really going to know the difference between these yet until maybe the next section, but you can just write that to find the numerical value of an expression. You might think, well, isn't that the same thing? In this case, yeah. But when we bring in variables like x, y, etc., it changes a little bit what these two words mean. And our last vocab word here, the order of operations, which you all are familiar with. That's why today is a review. So we haven't got around to hanging this thing up yet because it fell. But I have the 10 Commandments of Math poster. One of my favorite posters. All right. Let's see. Leah, would you do me a favor and read number 5 for everybody, please? Thou shalt honor the correct order of operations, guys. All right. That's on the 10 Commandments of Math, so you know it's important. All right. This thing's even laminated too, so I couldn't even change that if I wanted to. All right. I always get a kick out of kids that'll ask me when I give them a problem. They'll call me over and they're super serious. They're like, Mr. Lux, on this problem here, do you want us to use the order of operations or not? And I'm like, you always use the order of operations. That's why we have them. They don't ever change. That's the rules that you need to follow. That's like calling me over and being like, Mr. Lux, so, you know, like, do you want me to add when I see this symbol, or should I subtract now? Like, that's still addition, all right? That hasn't changed, okay? So the answer to that question invariably will always be yes. Use the order of operations when you're simplifying an expression, okay? Now let's quickly go through these. I know you guys have all probably learned a song, mnemonic device of some sort. What do we do first? Anytime you get a problem. JC? Parentheses. Yeah, any sort of parentheses or grouping symbols. And you can fill this in as we go. Just parentheses or grouping symbols. We're going to start using brackets a little bit, which function in the same manner as parentheses. Brackets just kind of look like that. I use those whenever I have like parentheses inside of parentheses. All right, so after you go into the parentheses, what are you looking for next? Amelia? Exponents, correct. Now, we won't be doing exponents for several sections, so you won't have to worry about that for a little while, but you have to acknowledge that that's part of the order of operations. Step 3. Finn? No. Before that, Quinn? Multiplication, division. Now, tell me about that. Multiplication and division, so that means we do multiplication first, then we do division second. No? When you do what, Jack? How do I know which one comes first? Left to right. Yeah, it's like reading a book, right? So as we read left to right, whichever one comes first. I think sometimes we make that mistake because all of our ways of remembering the order of operations, like PEMDAS or please excuse my dear Aunt Sally, always put the M before the D, so kids sometimes think, oh, multiplication before division. It doesn't work that way. Step 4, Finn. There's your addition, subtraction. Same thing, left to right. Okay? All right. Now, let me skip that. I've got a couple pretty basic setup problems here for us, guys. Not to challenge you intellectually. This is insulting if these would challenge you intellectually. This is more or less just to show you my expectation for what I want to see in terms of work. Now, anytime you do a problem that involves simplifying, I want to see all of the steps that go into it. Even if you're doing them in your head, you're not going to impress me by not showing me work. In fact, that works actually the opposite way, all right? I'm very unimpressed by that. Show me the steps. It doesn't take you long. but show me the steps. So on number 1 here, what are we doing first? We only have 2 operations. Which one are we doing? JC? And you get? Yeah, so some kids like to do like the little arrow to show what they're doing. Not necessary, but fine by me. But I always like to recopy after I do one step. So this is me showing work. Did the one step, got it to there. Now, obviously, the only thing left is this to get 21. Now, if you were doing this work, how long would you estimate scribbling that much onto a paper would actually take? There? Not even 30 seconds. I was going to say like 5 seconds, right? Boom, boom, boom. You write it in, you're done. Okay? So that's why I'm always amazed when people get upset when I ask them to show work. They're like, oh, show work? You know how long that's going to take? Yeah, I do. It doesn't take that long. Okay? The benefit of it is that if we make a mistake, we can easily identify that mistake. And that's why I want it, so I can help you with it. Same thing on number 2. Very basic problem, but the point of this was to show you just what type of work I want you to show. Okay? All right, take a look at your number 3. Number 3, we step it up a little bit here. Number 3 is different because now it has set up like a fraction. So go ahead and solve 3, simplify 3. Check it with your neighbor when you get it. See if they get the same thing as you do. Remember to show it. Show your steps. Yeah. I don't know. It's published by Carolina Mathematics. Maybe they determined that. Perhaps. Did you guys agree on number 3? Let's go over 3 first before we move to 4. Number 3, what do we get? If you check with your neighbors, do you agree upon an answer maybe? Leah, what do you have? Did anyone else get 1? Good. Okay. Now take us through, Leah, and tell us what you did, please. Yeah, I'm just kind of catching up with what she did. I'm just showing step by step. So she did this. She ended up there. 12 minus 3. She already got 9 here. Simplify 9 by 9. You get 1. I agree. All right, but I'm going to ask you a question here. I thought we had to follow the order of operations every single time. Right? I showed you a laminated piece of paper. So why was her last step, and I'm assuming your step, division? You knocked out some subtraction before you did division? That's not right. Mikey? Why not, though? And I agree, it doesn't. Why not? She didn't do anything wrong, by the way. Everything is correct, exactly the way I would have done it. Amelia? Right. So why are we doing that last, though, when we have subtraction mixed in there? Jack? Numerator, denominator? Yeah. Exactly. You're treating these as two separate problems. Or another way to think of it is just treat them like they're both wrapped in parentheses. Separate expressions. So you'd simplify these parentheses, then you divide last. All right? Let's try that last one. Or not the last one, the fourth one. And then also check with somebody. If you get that one done and you're waiting, go ahead and try the last one. We'll probably only have time to go through number 4. You can start. Yeah, we probably won't have time to finish that one today, but that's okay. Okay. So, taking a quick walk, looking at the answers, listening to the discussions. A lot of very common answers here on number 4. What did you get, you and your neighbors maybe, your partner get for number 4? Hayden? 6. Anybody else get 6? Anybody not get 6? Because 6 isn't right. Oh man, I wish you guys could have seen the collective looks I got from everybody. What is it, Jack? 96. Jack, quickly talk us through why this is 96, please. I'm just going to rewrite with what he's at. Okay, go ahead. Well, hold on, Jack. I thought these are parentheses. I thought we do these first. Why do we have these parentheses here? To show what? That is multiplication. That's all that's for, guys, was to show the operation. That was the tricky one. All right. I'll see you Monday. See you Tuesday. Sorry.